Welcome back, guys. This is a series in which I am trying to explain or share my knowledge on machine learning with the world. Thank you for watching my video. A quick recap on machine learning process. On high level, these are the 5 steps, which includes gathering data from various sources, cleaning data to have homogeneity, model building, selecting the right ML algorithm, gaining insights from the model's results, and data visualization. There are different types of machine learning algorithms: supervised learning and unsupervised learning. Classification and regression are two parts of supervised learning, whereas clustering is an unsupervised learning technique. Now, what is regression? Regression is all about finding correlation between different variables. For example, given a height, can we correlate and tell the weight? Or say this funny example. Yesterday, no husbands, today she got married. So today there are one husband. So as you can see, you extrapolate this, what will happen? Or by late next month you will have over a dozen of husbands. Funny, isn't it? So we have seen an example on linear regression in one of the previous videos. In this video I would like to explain a little more on linear regression through and take you through a sample. So for rest of the slides I have taken an example explained by Pradeep Menon in this particular Medium post. Thank you. So assume Fernando wants to buy a car. If he uses a simple linear regression model to estimate the price of the car, so given the engine size, I want to predict price. Maybe I have two parameters, the y-intercept as some constant and a slope as another constant, with which I determine the price. So the generalization of this relationship can be expressed as y equal to f of x, which is nothing but define y as a function of x. What if the dependent variable needs to be expressed in terms of more than one independent variable? So it may become y equal to f of x comma z. It's a 3D here. And when you need to express a variable in terms of two other variables, it will become a plane. It becomes a plane. So the plane is like y is a function of x and z. So maybe y is equal to m1x plus m2z plus z, where x is the first independent variable, m1 is the slope of x1, and z is the second independent variable, m2 is the slope of z, and c is the intercept. But when multiple independent variables contributing to the dependent variable happens, multiple coefficients to determine and complex computation will result. So the equation will look like this: y equal to maybe beta 0 or alpha plus beta 1 x1, beta 2 x2, etc. And you can have the cost function as given here. Cost function is 1 over 2m sigma yi minus yi, where capital yi is the estimate of ith component of dependent variable. So back to our car example, we can take multiple parameters, including make, fuel type, number of doors, drive wheels, and finally represent the price as a function of all these, maybe some of these. So see here, for example, price as a function of engine size, horsepower, peak, RPM, length, width and height. So maybe alpha plus different beta parameters for each of these. So you have all these parameters which is given to your model and given some values for all these in weights and the intercept, you will get a y. So the model building is all about finding out what are the different values for or what are the weight coefficients that you should give for each value and determine the intercept. So if you take this example, for example engine size, with all other predictors held constant, if engine size is increased by 1 unit, average price increases by 102.85. So based on the given input, I might have determined by trial and error. So how do we build the model? If we have n independent variables in our training data, our matrix X has n plus 1 rows, where the first row is the zeroth term added to each vector of independent variables, which has a value of 1. So x is equal to x1 all the way xn, and xi contains n entries corresponding to each feature in training data of ith entry. So matrix X has m rows and n plus 1 columns. So our final equation looks like y equal to xc. To calculate the coefficients, we need n plus 1 equations, and we get them from the minimizing condition of the error function. So equating the partial derivatives of the error function with each of the coefficients, what we get is x transpose x, the whole inverse x transpose y. And this leads to the resulting matrix C. So Fernando first evaluates a model on the training data. For a single variable, the result shows like this. You get your output and you're trying to determine or compare that with the actual value, and some parameters used to evaluate the performance of regression metrics are things like residual standard error, multiple R squared error, etc. So model evaluation, first one is beta 1. The value of beta 1 determines the relationship between price and engine size. If beta 1 equal to 0, there is no relationship. In this case, beta 1 is positive. It implies there is some positive relationship between price and engine size. And what about t-stat? The t-stat is the t-stat value is how many standard deviations the coefficient estimate is far away from 0. Further it is away from 0, stronger the relationship between price and engine size. The coefficient is significant. In this case, t-stat is 21.09. It is far enough from 0. And the next parameter is p-value. It is a probability value which indicates the chance of seeing the given t-stats under the assumption that null hypothesis is true. If p-value is very small, it implies probability that this is by chance and there is no relation is very low. In this case, p-value is very small, 1.27 e to the power minus 10. It means that the relationship between price and engine is not by chance. So model evaluation, to get a feel of accuracy of the model, we use a metric called R squared or coefficient of determination. To understand this matrix, we break it down into different its components. you have predicted value and actual value. So combining them, you can find the residual error, and squared and sum of that error is residual sum of squares. Then you have the actual value and the mean actual value, which is then converted to square and sum to form total sum of squares. Now r squared is 1 minus residual sum of squares over total sum of squares. So here the error is the difference between the actual y and the predicted y. They are also called as residual. Then all the residual values are squared and added, which is called residual sum of squares. Lower the RSS, better it is. There is another important part of the equation, as I said before, which is the total sum of squares. So to get this part, we calculate the mean value of the actual target, which is nothing but average value of the price of the car. Then difference between mean value and actual value, and these differences are squared and added. And finally our metric r squared, also called as coefficient of determination, which is 1 minus RSS over TSS. So the higher the value, the better the model can explain the variance. In this example, in our previous example, RSS is computed based on the price of the 3 cars, and the value is something like this. The mean value of the actual price is something 11,021. Finally, the RSS R squared is computed as 6.737. For these 3 data points, the model is only able to explain 6.73% of the variation, which is not good enough. For Fernando's model, it's a different story because we had more data. So when we calculate R square for that, it comes to 75%. That means the model can explain 75% of the model variation, which is very good, isn't it? And we can continue doing the same for our multivariate regression. And here, when we have a lot of R square, now when more variables are added, we calculate a new variable called adjusted R squared. It is a modified version of R square that has been adjusted for number of predictors. It compensates for the additional variables and only increases the new term, enhances the model. So in this example, the adjusted R squared comes to 81.1%, which is very good. So if you go through various parameters, all variables except length has an impact on the price, because only for length the p-value is very high. With that, let me thank you. Hope you are liking these videos. Thank you for watching my video. Please feel free to subscribe, share, and give comments and feedback.